We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Next concept is a loop disk scheduling algorithm. I have already explained scan and syscan, so I will also explain look and clook with the same question. Okay, so in that look, in the look disk scheduling algorithm, total disk is 200, so here 0 to 199, and then as per the question the total request, I put the total request track into the ascending order, so 16, 24, 43 up to 190. Okay, and direction, the direction is towards a large value. Okay, so towards a large value means my direction is a left to right, so I moves to the from left to right. Okay, so my current position is a 50, and then after I move to the second, then after I move to the second step. Okay, so second position is a 82, because the track request is 82. It is a right, it is a sorry, I move to the left to right, so 82 is a right side of the 50, so 50 to 82, then after 82 to 140, 140 to 170, and 170 to 190. There is a difference between scan and look. So what is the difference is that in the scan algorithm we reach to the end value 199 or 0. Okay, if we move to the towards a large value, then we reach to the one end value, so it's a 199. If my direction is towards a small value, then we move to the end value is a 0. Okay, so in the look algorithm, in the look disk scheduling algorithm, if we start with the current position, then we move to the end of the request track. Okay, so 199 is a last request track of this direction left to right. Okay, so here we move the 50 to 82, then 82 to 140, 140 to 170, and 170 to 190, and 190 is a last request track. Okay, of the same direction. Okay, at we reach the end, at the end position, then we move to the reverse direction, so we move to the into the reverse direction 190 to 43. So then after we then after 43 to 24, and last request track is a 16. So in the look direction, when we reach at the request track, at the end of the request track, so then after we move into the reverse direction, and at last we reach to the end of the request track. Okay, so we find out the total movement based on look algorithm, disk scheduling algorithm. So we apply this equation, so 50 to 82, so my movement is of 50 to 82, so 82 large value minus small value, so 82 minus 50 plus 140 minus 82 plus 170 minus 140 plus 190 minus 170 plus then 190 to 43. So 190 minus 43, then 43 to 24. So 43 minus 24, and at last 24 minus 16. So we can apply this equation, we can get the 314. Okay, and that is one shortcut. So based on this shortcut, 50, we consider the 50 and end of the request track of the same direction. So it's a last request track is a 190. So 190 minus 50 plus 190 minus last request track is a 16. So 190 minus 16. So we can get the 314. So it's a look disk scheduling algorithm. And look and scan is a most of same disk scheduling algorithm. The concept is same, but there is a difference for choosing the end value. Okay, so my last disk scheduling algorithm is a C look, and it is a circular look. In the circular look, for the circular look I consider the same question as well as FCFS, SSTF, scan, syscan, look and C look. So I consider the same question. So my total disk track my total track is as 200, so 0 to 199, and I put all the request track into the ascending order. So 16, 24, 43, 50, 82, 140, 170 up to 190. Okay, so in the C look, in the circular look, we start with the current position 50, then my direction is a larger towards a larger side. So I move the 50 to 80. So 150 to 80, then 80 to 140, 140 to 170, and 170 to 190. And in the circular look, it is a totally depend on end to end. Okay, so in the say look, the end value is a last request track of the same direction. So if I consider this direction, then last request track is a 190. So my end value is a 190. Okay, and when we consider this, so when I reach at the one end, then it is connect to the directly with the second end. Okay, so 192. Okay, my second end is a 16, because 16 is a last request track of the reverse direction. So in this, if I consider this reverse direction, then it is a last track of the this direction. So when we reach the at the 16, then we consider in the again reverse direction. So we traverse the 24 and 43. It means when we reach at the one end 190 or 60, whatever, then we first when we reach at the one end, then we directly move to the another end. Okay, so we cannot traverse between end to end direction. Okay, we cannot traverse any value from this both end. Okay, so when we reach the one end 190, then we move to the another end, it is a 16. Then after 24, and last one is 43. So it is a C look, circular look. Okay, so it is the same as a C scan. In the C scan, my ending value is a 199 and another ending value is a 0. But in the C look, my ending value is a last request tag is a 190 and another request tag, last request tag is a 16. So it is a end value for the C look. Okay, so we find the total movement, total seek time movement. Okay, so we can apply this equation on based on this traversal. Okay, so first one is 82 minus 50 plus 140 minus 82 plus 170 minus 140 plus 190 minus 170 plus 190 minus 16 plus 24 minus 16 plus 43 minus 24. We can get the value 341. Okay, but there is one shortcut, so I apply here one shortcut, and shortcut is a end to end. Okay, so it is a 50 current position, then direct consider the end value is a 190. So one large value minus small value, so 190 minus 50. Okay, so and second end is a 16. So 190 minus 16. Another end value is 43. So large value minus small value. So 43 minus 16. So we at the last we can get the 341. Okay. So here I have completed all the disk scheduling algorithm. Okay. Thank you.